Alright, in this video we're going to find the work done, the physical work done, in applying a force to an object. So in physics, the constant force is exerted over a distance, which really we call it a displacement because it measures where you start versus where you end up, much like a vector does. If that displacement is, we give the letter d, then the total amount of work done by that force is going to be given by the force times d. So in other words, if you pick up a 100-pound weight and move it 30 feet, then you have done 100 times 30 or 3,000 foot-pounds of work. If you pick up the 100-pound weight, move it 30 feet, and then move it back to where you originally had it, you've done zero because your displacement is zero, not the actual distance that you may have covered. So if the force being applied is not in the direction of motion, we can use the dot product to find the work done. So here we have our force not parallel to our displacement vector. So maybe it's going upwards, maybe it's going anywhere really, and it's going to form an angle. And then the work done is the magnitude of the force that's being applied times the magnitude of the displacement, how far it went, times the cosine of the angle that they make. So if they don't make an angle at all, if they're parallel, then it's just d times f, the displacement times f. Or in terms of what we've talked about in this unit, in this section, magnitude of f times the magnitude of d times cosine of theta is vector f dot vector d. So Mr. Bain exerts a force of 230 pounds to pull a stack of rocks a distance of 50 feet over level ground, because he's strong like that, of course. If the rope makes a 30-degree angle with the horizontal ground, how much work did Mr. Bain do pulling the rocks? A lot more work than he normally does, I can tell you that much. Assume Mr. Bain does exert the 230 pounds at a 30-degree angle for the duration, so I don't get tired after a while. I'm just that strong, of course I am. So looking at our information here, we have 230 pounds of force. Our displacement is 50 feet, and the angle that the rope is making with the ground is 30 degrees. So it's almost like pulling a wagon that has 230 pounds of rocks sitting in it, and the handle's making a 30-degree angle with the horizontal, and you're moving that wagon 50 feet. I guess I shouldn't use a wagon because a wagon has wheels and it's a lot easier, but you get the idea. So we have 230 pounds of force. We're pulling at 50 feet, and the angle that the rope is making with the ground is 30 degrees. So when we plug all that in, we get 11,500 foot-pounds times 230 times 50, 11,500 foot-pounds times cosine of 30 degrees is the square root of 3 over 2. And that turns out to be roughly 9,960-ish foot-pounds of work. So you can imagine pulling 230 pounds of rocks 50 feet, dragging them on the ground. It's going to take a lot of work, and here's the amount that it takes. So, all right, that about does it for this section. I will see you next time.